Hello and welcome to another video. Today's topic is transformations of functions, and what I have in front of you is all the questions that are part of transformations of functions. So we will start doing the questions. I will stop in the middle after each question and check the marking scheme because it's important to get you the right answers. Let me just open up my marking scheme documents. This is a tough one. Okay, so let's begin. This is the first question. This measures transformation of functions and trigonometry together. The diagram shows two curves. One curve has equation this and the other curve has equation that. In order to transform y equals to sine x to the graph of y equals to f of x, the graph sine x is first reflected in the x-axis. Okay, describe completely fully a sequence of two further transformations. So I know that I've reached minus sine x. Okay, so minus sine x would look something like this if I were to draw it here for you. Okay, I know that there is a stretch involved and there's a translation sort of involved as well, and I will have to be do a little guesswork. There is no essentially guesswork. I can see that there's a false axis existing here, so I know that there's something called minus sine x minus 2. That means there is a translation of 2 units down. And then there is a stretch involved as well, because I see the amplitude sort of has changed. The amplitude was 1 before and the amplitude is right now 3, so that should give me minus 3 sine x minus 2. Okay, and let me check if the period has changed. Okay, so I don't think the period has changed. There's one complete cycle, so there's just two further transformations. You will always state the stretch first and then the translation. So it's a stretch with a vertical stretch with a factor of 3 followed by translation 0 minus 2. Okay, let's check if we have the right answers. I don't know what year this is, but I'll have to open it up. This is June 24 1 Okay, so that's question number 2. Okay, yeah, those are the correct answers. Stretch factor 3 in y direction and then that. Okay, moving on, let's look at the next question then. It says behind f of x in terms of sine x. I've already done that for you. Just going to restate it. Okay, I think that should be the correct answer as well. Yeah, that is the correct answer. Okay, then this is a question from June 24 1 2. It says y equals to x squared is transformed to the curve y equals to 4x minus 3 whole square minus 8. Describe fully a set of transformations that have been combined, making clear the order in which the transformations have been applied. So I always advise you to do the x transformations first. The transformations in x are basically, so I'm going to call that the first one. In x are basically 3 units. It's a translation. 3 units to the left, or with vector 3 0 if you please. To the right, sorry, my bad, to the right. You do the opposite, so 3 0, yeah. Okay, and then for the y transformations, I'm going to say transformations in y. I'm going to call that the second transformation. Transformations in y, so that's the second transformation. It's going to be the stretch vertical factor 4, translate down 8 units, 0 minus 8. Okay, let's again check if those are the correct answers for me. You see 5 not very difficult marks. You just need to be aware of what's getting multiplied first and what's getting subtracted first. Okay, yeah, those are the correct answers. No issues with that. Okay, for the next part, next question we have this. The diagram shows part of the curve this. If k is a positive constant and x is measured in radians, the curve has a minimum point at A. Okay, now typically the sine curve is goes from 90 to 180 to 270 and 360, but that's the normal case of a sine x graph. Now I noticed that this no longer is a sine x graph. What I know is that all x coordinates have been multiplied by 2. Remember that the transformations in x are the opposite of what they are written as. So this point is no longer 90, this is 90, that is 180. Okay, so this has to be 45 and this has to be, no, my bad, all of the x coordinates have been multiplied by 2. I'm doing the opposite. That's 180, that's 360, and that has to be 720. So in the middle I have 540. Okay, so in that case all x coordinates have been multiplied by 2, so my minimum point has to be at 540. So half of 540 degrees. I can put that in radians as well. I will use my calculator at this point. I don't know if I have my calculator here. Yeah, I have my calculator here. The sine of 270, basically sine of 540, that gives me -1, so this should become minus k. Okay, so the coordinates of A are 540 in radians is I will have to convert that too. Okay, so that's 3 pi basically. So 3 pi comma minus k. I think that should be the correct answer. A sequence of transformations applied to curve in the following order: translation of 2 units in the negative y direction and reflection in the x-axis. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. So the original curve is y equals to a sine half x. Let's do the transformations. Translation 2 units in the negative y direction, that would give me a sine half x minus 2, and then reflection in the x-axis would mean minus f of x. So all of these have a minus then multiplied with them, so that gives me plus 2. Okay, so that is the equation of the new curve, and determine the coordinates of the point on the new curve corresponding to A. So it's going to be 3 pi minus k minus 2 for the first step, and then 3 pi k plus 2 for the second step. Okay, checking from the marking scheme if I have the correct answers. I have 3 pi minus k as the first answer, and then the correct, yeah, all of these are correct. Okay, moving on to the next question. This is question number 8 from November 2313. Let's start solving this. It says the diagram shows part of the curve y equals to sine ax plus b, where a and b are positive constants. State the value of a and one possible value of b. Okay, so this curve has both been translated and stretched in the x-axis. Now, if you remember one of my transformation videos, I told you in the past that what you have to do is, in this case, it's going to be the stretch first and then the translation. Okay, so that's what I have to think about. I don't know how that would affect this question, but I'm just trying to see if I can figure out the right answer based on something that will help me solve it. Okay. Okay, so what I think is that the stretching wouldn't have impacted this. It's the stretch first and then the translation, so the stretching wouldn't have impacted this. It's moved back 1 over 3 pi. So I can say that b has to be 1 over 3 pi. Okay. Then if everything has moved back 1 over 3 pi, can I then try to figure out based on some value what the value of a would be? Okay, so 1 equals to sine. Okay, so that's giving me sine a pi. Sine inverse of 1 gives me pi over 2. So a should be half. I'm not sure about this one. I'm going to check and come back. November 2313. Let's see if the question gives me some other way of doing it. November 2313. Question 8. Yep, those are the two correct answers. Although I think this one is half as challenging. What I generally tend to do is, once I figure out one of the unknowns, my general way of doing it is to sort of then use coordinates to solve the question. I am not sure how else I would have done this question, but I will think about that and get back to you. Okay. Another curve with equation y equals to f of x has a stationary point at p comma q where p and q are constants. This curve is transformed to the curve with equation this. For the transformed curve, find the coordinates of the stationary point, giving your answer in terms of p and q. Okay, so if the original was p and q, I see that there is a reflection and a stretch for the y coordinate, so that's going to become p comma minus 3q. Okay, I'm going to do it step by step. Then for the x, I have two sort of transformations, and I've already always told you that if you have these in a bracket, what you do is you stretch first and then you solve the bracket for x transformations. So I'm going to say that this becomes 1, so it's going to be the opposite of as it's written as. So it's first going to become 4p minus 3q, and then I need to subtract 8 from all of it, so 4p minus 8 comma minus 3q. Okay, that should be the final answer. Let me check if those are the correct answers. Yes, I have. In case you don't know what I did determined here, there is a video on transformations of functions that I would want you to watch, where I explain this to you. Okay, the transformation R denotes a reflection in the x-axis, and the transformation T denotes a translation of 3 comma minus 1. R followed by T. Okay, so reflection in the x-axis is simply minus attached to it, and for the translation I'm going to say that this becomes then x minus 3 and then minus 1 outside. Square. Okay, I just want to check if I have the -1 correct. This is from November 23 1 November 23 1 Question 4. Yep, that is the correct answer for the first part. It says then if after it has been transformed by a sequence of t followed by r, so that's in the reverse, then first I get x minus 3 whole square minus 1, and then when I do a reflection it becomes minus x minus 3 whole square plus 1, because then the negative sign comes with all of them. Straightforwardly, the transformation that maps the curve y equals to g of x onto the curve y equals to h of x. Okay, from g of x to h of x. So g of x is this one and h of x is this one. So I see there's only a movement on the y translation. So it's translation. I went from -1 to 1. So that's 0 and 2. Okay, I think that's simple. Okay, then this is a tough graph. Okay, let's try to do this because both the axes are in radians. Okay, the diagram shows part of the curve. This complete the sketch of the graph on the diagram. Show the above on the diagram above, and hence explain whether the function g has an inverse. Okay, it's not completed up till the other point, so I'm going to need another set of coordinates that I can plot. Okay, what I think is that it simply is has to be symmetric, since I see no movement translation on the x-axis. So what I'm going to simply do is, I can also use my calculator here. The only problem is that I don't know the step. In any case, I am going to say, in fact, I should use my calculator, I think. Let's go and use our calculators. I have the table in front of me. I've forgotten the function. 3 plus 2 sine 1/4 x. 3 plus 2 sine. Okay, just to be absolutely flawless on this, I'm going to calculate in radians because both the axes are in radians, and that's sort of bothering me a little. Okay. So although the question requires, I have the axis very clearly in front of me, I'm going to say that I am going from -2 pi to 2 pi. And let's just keep a step of pi over 2 because I think those are the numbers that are marked there. Okay. Okay, let's see the numbers that are marked for me. Do I have 0 and 3, or have I made a mistake? No, that's 0 and 3. That's 3 marked. A little before 3.142. Okay, so let's mark the other ones then. 1 minus 1.57 should give you 2.2346. I don't know how to get that, but I will have to estimate a little. Or let's go to see. Yeah, that feels like pi over 2. So I'm going to say that on minus pi, I have pi over 2. So minus pi should be pi over 2. Okay, yeah, that feels fine. Okay, now how would I do this without a calculator? The simple idea is that I would I should keep it a little above that as well. Okay, how would I do this without a calculator? I would say that it has to be a replica of the graph. So I'm going to, watch out for this distance. What is this distance? This is like 2 complete boxes and 3. So I'm going to go with 2 complete boxes and then some more. So I'm going to plot it somewhere here and then, go sort of judge what's written there. So the previous step is then 1.152 and the last one is 1. So I know that at minus 2 pi I will definitely have 1, but you see this axis is no longer in, it's 1.57 somewhere, so I know that it's going to be somewhere in the middle somewhere. So that's how I would complete that figure. Okay, that is what my curve would look like, challenging that way. Okay, yes, it is 1 to 1, so it has an inverse. Okay, let's see what the marking scheme says in this one. What is the mark for? I'm not absolutely sure. So 2312. Okay, yeah, I think that is the correct answer. And the correct square. Yeah, okay, that is the correct answer. Describe fully which can be combined to transform y equals to sine x to the graph of y equals to x, f of x, making clear the order in which the transformations are applied. 3 transformations. So I can clearly see 3 transformations. So I'm going to first say horizontal stretch, factor 4, vertical stretch, factor 2, and vertical translation 0 2. I think that's the easy part of this question. Okay, 0 3, sorry, 0 3, not 0 2, 0 3. Okay, moving on to the next question that I have for you. The diagram shows the graph of y equals to f of x, which consists of 2 straight lines AB and BC. The lines A dash B dash C dash, which is the result of applying a sequence of 2 transformations in either order to y equals to f of x. So I see that it's stretched horizontally. Previously, this distance is new as 6 units, and this was 3 units before. So I think there's a double happening on the x-axis. So I'm going to say that this is f of half x. Okay, so f of half x, and then I see that there is some movement on the y-axis as well. How many units have I moved? I think I have moved up 2 units on all, so I'm going to say that this is plus 2. How do I describe them then? Statefully 2 sets of transformations. So horizontal stretch, factor 2, translation 0 2. I think those should be the correct answers. June 2313. I will have to again check. Okay, this seems like a lot of work in terms of transformations of functions. This question number 1. Okay, so the graph has moved downwards. My bad. I didn't notice this. This is 2 units down, so 2 units down. 0 minus 2. The other things are the same. Okay, question number 3 from June 23, 1. Okay, this also seems like a set of two transformations. I see that there's a vertical stretch this time. Okay, this distance seems to have gone from -3 to 3, so that was a distance of 6 units, and it's gone up to 12 units. So I see that there's a vertical stretch factor 2. Okay, what else do I see? I see that the graph seems to have moved horizontally, and it has from f of x to g of x sort of moved backwards. How many units backwards can I imagine? This is -1 and this is 5, so that's 6 units backwards. Okay, so translation 0 minus 6, minus 6 0. Okay, continuing with this, we have another question. It says a function f is defined by this. A sequence of transformations is applied in the following order to give the y equals to g of x. What I recommend is you create a different function for each step rather than doing it all in one go. So in this case, I have a stretch parallel to the x-axis with a scale factor 2. So I'm going to say that that gives me f of 2x. In that case, it's going to become 2x squared minus 2 times 2x plus 5, and that gives me 4x squared minus 4x plus 5. Then it's a reflection in the y-axis, so that's f of whatever is inside. So it's going to be f of minus x in this case. So I'm going to go with 4 times minus x squared minus 4 times minus x plus 5. So I get 4x squared plus 4x plus 5 stretch parallel to the y-axis with this factor of 3. That's 3f of x. That's going to be 12x squared plus 12x plus 15. Okay, I think that should be the correct answer. I don't know what year that is. February, March 23. February, March 23. Yep, that is the correct answer. Moving on, it says express it in the form x minus a whole square. So I use comparison to express this. So x squared minus 2ax plus a squared plus b. So minus 2a compares with minus 4, so a equals to 2. And 9 compares with a squared plus b, so 9 equals to 2 squared plus b. So b is 5. So x minus 2 whole square plus 5. Okay, this has a particular form to it. 2x squared plus 4x plus 12. 2x squared plus 2cx plus d squared plus d. So 2x squared plus 4cx plus 2c squared plus 2d. So 2 compares with 2, 4c compares with 4, c is 1, and 12 compares with 2c squared plus 2d. 2d equals to 10 and d equals to 5. So I have 2 bracket x plus 1 whole square plus 5. Previously I had x minus 2 whole square plus 5. Okay. Express g of x in the form k f of x plus h. Okay, so what is my g of x? I have a bit of a suspicion that this might not be written in the right way. Yeah, that is what I was missing. Okay, so this is 2 bracket x plus 1 whole square plus 5, and f of x is basically x minus 2 whole square plus 5. So what I see is that this sort of matches what is inside. The only thing that's changed is that I went from minus 2 to plus 1. That means that the turning point previously, if I just compare the inside, was 2 comma 5, and now it's minus 1 comma 5, which means that the graph has moved backwards. Each x was probably replaced with x plus 3. It's going to be f of x plus 3 for me to move the turning point 3 units backwards. Okay, and then there is a 2 outside, so that's the 2 outside. That's a vertical stretch once you've done all the movements in the translation. Okay, I think that should give you the correct answer. I will still have to check. There is one part left. Describe fully the transformations that have been combined to get the graph of y equals to x, f of x to the graph of y equals to g of x. So first there's a translation, minus 3 0, stretch, vertical, factor 2, and that's the order of the transformations. Okay, let's check if we have all of that correct. I don't know what year that is. Again, this is November 2211. Yeah, I have all these correct. That is correct. That is also correct. And that is also correct. Okay, I have solved this one before, but let's solve this again and then quickly move on. I don't know how many questions there are. There are a lot of them since I am on page number 12 of 23, so I'm just halfway through the handout that I have in front of me. Okay, starting, this is the diagram. So the curve has maximum points 812 and a minimum 0.80. The curve is a result of applying transformations to a circle. The first transformation applied as of 7 3. The second transformation is in the y direction. Original 7 minus 3, and then stretch y. State the scale factor of the stretch. Now, if this was a circle and it's only stretched vertically, then I could probably figure out the diameter of the original circle from here, and that looks like 4 units. Okay, when I see the diameter of the new circle, or the ellipse in this case, that's 12. That means there was a stretch factor of 3. State the radius of the original circle. So the original circle had a radius of 4 divided by 2, which is 2. State the coordinates of the center of the circle after translation has been completed, but before the stretch has been applied. So I want to go in the reverse now because I have the final one. Okay, now if I want to end up at this point, what I will have to do is I will have to reverse the stretch. How do I reverse the stretch? I divide every y coordinate by 3. So that comes up here, and this point comes up here. So that's the circle that was there after the stretch, after the translation, but before the stretch was applied. And this looks like a reasonable thing to have. Okay, then so what's the coordinate? The coordinate is 8 comma 2. State the coordinates of the center of the original circle. Now I will have to reverse the translation as well. I moved 7 units forwards and 3 units down. 7 units backwards. So I have on 8 comma 2. So 7 units backwards will take me to 1, and 3 units up will take me to 5. Okay, and those are the correct answers. That's what I've solved in the uh, videos as well. Okay, then this says, the next one says the graph of this is transformed with equation by a stretch in the x direction with a factor 0.5. Okay, so I have a factor of 0.5 followed by a translation of 0, 1. The diagram below shows the graph from the sketch. Draw the gram of y equals to g of x. So let's first stretch. Factor of 0.5 would make the stretch something like this. Okay, so this point would appear here. And then I would have another one here. Okay, and followed by a translation of 0, 1. So 1 unit up. That should be my final graph that you should be able to see on the diagram. Okay. G of x in terms of f of x. G of x would be, there's a horizontal stretch and a vertical translation, so that's simple. F of 2x plus 1. Okay, then I have the graph. This describe fully a set of transformations, making clear the order in which the transformations are applied. Now this is where it gets a little tricky. So the simple idea is, when you there's a vertical stretch factor 4, you could write that up first or write that at the end. That's your choice. Okay, factor 4. For the x, there are two transformations, half and minus 30. You have to decide which one happens first. In this case, what's going to happen first is you're going to stretch, you're going to translation 30, 0. Okay, and then stretch factor 2. Okay, if you are unwilling to do that, you will have to first do this, take a half common, and then change your translation and the order as well if you want. That's the correct order of this question. Okay, the curve with this, find the equation of the translated curve. So first I'm going to write it as this, so x plus 1 and plus 3. So every x will be replaced with x plus 1, and there's going to be a plus 3 at the end. So x squared plus 2x plus 1 plus 2x plus 2 minus 5 plus 3. So x squared plus 4x minus 5. Okay, so the y-intercept sort of has remained the same for some reason. Let me check if that is the correct answer. There's another part to this as well. Let's first do that. Okay, so what I notice is that the x squared became 4x. This becomes this. This doesn't change. That means that there's a horizontal stretch involved. There's no vertical stretch involved. Horizontal stretch, and I see that every x has been replaced with 2x. The horizontal stretch factor half is basically f of 2x that you've calculated here. Okay, let me check if those are the correct answers. 1, 3, June 2, 2. Oh, I think I've made a mistake here. That's what I was wondering. 1, 2, 3, and then plus 1. Okay, let's do another one that's very similar to the one that we did before. So 2x square minus 8x plus 14, then 2x square minus 2ax plus a square plus b So 2 is equals to 2 minus 4a equals to 8 minus 8. So plus 2. And 2a square plus 2b equals to 14. So 2b equals to 6 and b. So I have the form 2x minus 2 whole square plus 3. Okay, so there is a translation involved first. Translation 2 comma 3 1, and then there is a vertical stretch factor 2. Okay, question number 1. This is describe fully two transformations. So there is a reflection in the x-axis. Okay, and then there is a translation 0 3. This is from November 21 13. Then there's more. Describe fully the set of transformations that have been combined. So I see a transformation in x, horizontal stretch. Factor of vertical translation 0 minus 3. Okay, the point P this, state the coordinates of the corresponding point on the original curve y equals lies on the transformed curve. So I have to do these in reverse now. Okay, so this has already been halved. It would have been originally 10. And this is 3 units down, so I have to take this 3 units up. So that could be 10 comma 9. Okay, then there's a very similar question next. Let's do this quickly. This is a long question. And then we're going to do a comparison. Minus 3 matches minus 3, 6a should match with 12. And minus 3a square plus b should match 2. So minus 12 plus b is 14, I think. Minus 3x minus 2 whole square plus 14. Okay, the found one function is this. So that's the x coordinate of the turning point. So that should be 2, k should be 2. That's where you need to cut the curve in order for you to have a one-to-one function. And one-to-one functions have inverses. It is now given that k is equals to minus 1, state the range of f. So the graph currently looks like a sat face like that, with the turning point at 2 comma 14. But you want to cut that at minus 1 instead. Okay, so what's the value at minus 1? Let's figure that out. Cos 12 times 1. So that gives me 14 minus 11. So minus 1 comma 11. So the rest of the graph is absent. What you have is from x is less than or equals to minus 1. So only a certain part of the graph is present, and that's this part. So where are the values going? The values are going downwards from here. So y is less than or equals to 11, because that's the only part of the curve that's present. Then I want to find the inverse. If you've done the inverse with me in the functions chapter, that this would make sense to you. So y minus 14. So let's do 3x minus 2 whole square equals to 14 minus y. x minus 2 whole square equals to 14 minus 5 over 3, and I take a root, and I'm going to take a negative outside the root because the negative part of the curve is present, and x is therefore equals to this. So f inverse of x is minus 14 minus y, or 14 minus x. Okay, and then the graph of this is translated. So f of x plus 3 plus 1. What was the original f of x? It was minus 3x minus 2 whole square. Do I need it in a particular form? I need it in that form. Let's just do that form. Minus 3x squared plus 12x plus 2 minus 3x squared plus 12x plus 2. Okay, so g of x is then every x needs to be replaced with x plus 3. Minus 3x squared minus 18x minus 27 plus 12x plus 39 minus 3x squared minus 6x plus 12. Okay, yeah, that makes sense, I think. I will have to check these answers though, they're a long set of questions, so I think I might have gotten that number wrong. Okay, let me check if I have the calculations wrong. Yes, I have the calculations wrong. Minus 3 minus 12 plus 2, so that's minus 13. Okay, the rest of it is fine. I also have part E correct. Yeah. Okay, next question. I think that should be second last question or the last question, I'm not sure. Yeah, 3 more questions. Let's quickly wind them up. This is a horizontal translation 10, vertical stretch 2. Is reflected in the y-axis. So for the y-axis you have f of minus x. So y equals to sine of minus 2x and minus 5 minus x. So I have sine of minus 2x plus 5x. And then stretched by scale factor 1/3 in the x direction. Okay, so that means I will have to now do f of 3x. So y equals to sine of minus 6x plus 15x now. Okay, not 15, sorry, yeah, 3 times 15, 5 is 15, yeah, 15x. Okay, that should be the final equation that I have. Then express f of x and g of x in completed square form. So if I haven't given you completed square forms, you can use the general idea that it's going to be ax minus h whole square plus k. So a x square minus 2xh plus h square plus k. So ax square minus 2axh plus ah square plus k. A equals to 1, minus 2 equals to minus 2ah. So h equals to 1. So ah square plus k equals to 5, 1, 1 square plus k equals to 5, k equals to 4. So 1x minus 1 whole square plus 4. It's 2xh is 1. So I have x minus 2 whole square plus 2 whole square. And I have plus 9. So that's the transformation that I need to talk about. Okay, so what transformations have happened? And g of x is this one. So the turning point, every x has been replaced with x plus 3, I think, and then there's a 5 outside, so f of x plus 3 plus 5. I think that should be the correct answer. That's the transition from here to here. You can see probably the 5 plus 5 clearly. I've moved from minus 1 to plus 2. That means I've added 3. So that's f of x plus 3 plus 5. Okay, what transformations would I suggest? This is a translation with minus 3 and 5. Okay, let's quickly check if that is the correct answer indeed. Question number 6. Yep, those are the correct answers. Let's do the last one. It says in the diagram this, the diagram shows with broken lines. The transformation this, describe fully the two transformations. Now, when I notice this diagram, there's nothing horizontal happening on this apart from a movement from here to here. I know there's a horizontal transformation involved, but my gut feeling is always to do the stretches first. So I see that this is a distance of 3 units and this is a distance of 1 unit. So there's a vertical stretch. And I'm going to write that first. Factor 3. I'll decide if I want to change the order then. Okay. And if I look at this, there is a horizontal transformation after that. There is, I think, no vertical transformation involved. It's just a vertical stretch involved. And let's see if I'm able to get this right. So if I stretch this vertically, this 2 point comes on to 6, and then 3, like that, and then like that. Okay, so I see that there's no need to translate it vertically, there's just need to move it horizontally forward. And how many units have I moved horizontally forward? So I've gone from 0.5 to 4.5. So that's translation of 40. Y f of x is the equation of the graph with the broken line. That's going to be y stated in terms of y. Okay, f of x is 3 minus 4. Okay, and that should be the final answer. That brings me to the end of all transformation questions that I had from 2024 backwards to 2021. I hope this session was productive for you. Thank you for watching.
Welcome to Edge Learning, where we are changing dreams into success stories. Let's go. At Edge Learning, we offer courses to help you excel. Whether you're preparing for the SAT, aiming for IBA and LUMS, need O and Alevel tuition, or IELTS coaching, we have the right program for you. Forget about boundaries. We offer learning anywhere, anytime. Our expert tutors provide personalized attention in various batch sizes and one-on-one sessions, along with pre-exam review workshops to ensure you perform your best on test day. Join us at Edge Learning and take the first step towards turning your dreams into reality. So what are you waiting for? Register now or call us.